So, good afternoon. My name is Petr and I work at the University Center for Energy Effective Buildings within a group that is focused on monitoring and control of intelligent buildings. My special domain is photovoltaic systems and energy storage. Within today's presentation, I will discuss a project that is focused on predictive control of battery storage that we have where we have worked together with a company that manufactures the battery storage in Czech Republic. First of all, I would like to show and shortly discuss the functions of a battery system for a household. Because in this size, these battery storages have about 10 kilowatt hours of energy storage, and the functionalities and the intelligent control we have designed for such systems. The main function for such systems that somebody can install inside a, let's say, a small family house is to increase the photovoltaic energy for self-consumption. This means if somebody has already a photovoltaic system on the roof and adds a battery system to this energy system for the household, this battery can let's say increase the locally generated solar energy that is locally used. So there will be much less energy put to the grid. Most of the energy will be used for the purpose of the house. For this point, it is important to define the strategy how to control the battery, and the simple strategy is to keep the battery discharged, to wait for some extra additional energy from the photovoltaic system that can be then shortly stored to the battery and later on used for the house. But we want to add some additional functions like the uninterruptible power source. This is especially important for areas where the electrical grid is not stable, and for this purpose, the strategy is the opposite. It is important to keep the battery charged for a case that there will be some blackout, some energy outage from the grid. The system within the household, or let's say a small family house, can work independent on the electrical network. Then there are some additional functions like peak shaving and phase balancing. For example, these functions can improve the grid stability, and they can be beneficial in, for example, some remote areas where there is impossible to increase the power taken from the grid. If we want to implement some predictive strategy, we often have to have a good prediction for the energy consumption and also for the energy generation from the photovoltaic system. To achieve this, within the project we have worked on, we have implemented and tested our own developed new forecast service for short-term forecasting that was based on using a cheap, low-cost camera that was looking on the clouds. So, and we implemented some machine learning and some automatic detection of the clouds. So on the picture on the left side, you can see the image of the sky that is has already passed so-called segmentation, where the individual clouds, they are marked with colors. We have tracked the movements of the clouds that is on the picture in the middle. And based on the data processing, we then analyze the data, and we have received some short-term prediction of the solar irradiation. This solar irradiation is then important to deliver out a forecast for the solar output of a photovoltaic system on place. How to implement or how to use then these inputs for controlling the battery storage. There are I have already shown several functions of the battery storage, and when we want to balance in between having a battery fully charged or discharged for those functions, we have used in the end an simple algorithm where we have always defined based on a predictive control strategy and a possibly best state of charge of the battery for the next hour, and this was then put to the battery control system as some, let's say, aim for having for using the energy for the household either from the grid or from the battery. This is how our setup looks like. We have used professional sky imagers as on the picture here, as well as cheap low-cost cameras that have shown also a very good results, and the costs they were much lower. On the right side, you already see how the image processing was running. So we firstly have found the individual clouds, found their movements, and then we have in the end finalized the solar prediction. To find out how in the end it can be beneficial for an operator of such a system, we have done a quite short-term testing of this setup, where we have used a battery storage system that was connected to a preprocessing unit for generating the solar prediction from the sky imager. For having some local feedback, we have also used solar sensors to show us what is the real solar intensity on place. And most of the photovoltaic prediction was running on a cloud service, because it's quite a computational intensive part. This is how the experimental setup within the laboratory looked like, and these are already some of the results. We have used a 2 days analysis for finding out what can be the beneficial and of having a predictive control strategy of control to control a battery system for a typical household. And in the end, from some usual 2 days scenario, we have found that in the end the benefits can be for our case about 2% of energy saving from the grid. It can be seen on these graphs that when using the PV prediction control, we have a lower energy input from the grid than when it was not being implemented. And you can also here see that with the PV prediction control, the energy taken directly from the photovoltaic was increased. But to make some tests for 2 days, it doesn't tell us much. We are aware of that we must have some long-term testing that because in every period the weather differs. It can be also affected that the consumption of a house or of the households vary within a year. And we should run much more tests to have some kind of good reference data to prove what will be the real benefits. And so we still continue on this project, and now within the next step we want to have a longer term testing and showing what will be the real benefits. So thank you very much for your attention, and this is all from my presentation. Thank you.